Hey there. So, welcome back. We're going to be looking at a small language model today. I got to thinking if I wanted to actually use a language model in a standalone desktop app, I'm not going to want to require my end users to buy a subscription to one of the more popular language models, or even worse, pay for an API key so it can interact with my app. I want to be able to ship the language model with my app. And that got me thinking about small language models. But, how far can we push them? A definition of small language models I found on the Hugging Face site. 1 million to 10 billion parameters. So, a lot smaller than what we've become used to if you spend any time working with a language model. And there's some examples of language models here, like 1 billion parameters, 1.5 billion parameters. I have a 64 gigabyte laptop, 16 cores, which is enough for most of what I do. I'm not going to be able to run a 30 billion parameter model on it, and I could, it just wouldn't be a nice experience. So, how small can we go? As you see, there's a llama model, 1 billion parameters, which is alright. Wondering about licenses. If we're going to use this ourselves, if you're going to package a language model with an app, you have to pay attention to the licensing. And I read through this a little bit. Basically, you have to put some big stamps around your app saying that this was your app. This app was produced with Llama, and I don't know what else was hiding in that licensing agreement. This is a custom licensing agreement, which you just have to make sure you read the whole thing. I found the Quen model, which is actually half the size of the Llama model. And if we take a look there, that one uses the Apache 2 license, which I don't remember all of the rules, but I am more familiar with the license, so I have more inherent trust for the thing. And it's 0.5 billion parameters. So, it's a pretty tiny model. And we're going to be running it through the Ollama server. It's basically a server designed for deploying and running language models. So, Open Llama. So it was originally developed for the Llama language model, I believe. But it runs a lot of different models, including the Quen model that we're going to look at. So, what I want is a C# app that packages small, we're not going to package Ollama with our app. What it's going to do is download Ollama, install it to local app storage, and then launch it as a child process inside of our C# app, and make sure to kill it at the end. So it's going to be almost like Ollama is just embedded in our app. Using the same bootstrapping process from my last video. Wires up command line parameters. Width and height. That's not going to be relevant in what we're doing here. This is going to be a console app. I'll clean that stuff up later. Sets up dependency injection and executes the initial state that we feed it. And what we're doing in this little demo here, have the bootstrapper starts the run async method, and we have, most of the meat of what we're dealing with is in the Ollama runtime namespace. The Ollama manager kind of is the top level thing that contains everything else as far as Ollama goes. We are going to make sure it's installed, start the server, pull the model, list all of the installed models and the running models, and then stop. See if we can do that. And the GPU detector, I mean, I have things in there for detecting the GPU, but can't figure out how to wire it into Olama's command line parameters. I think that command line, part of the command line was deprecated. I'd have to come back around to that later, but I'm leaving it in place for now. You can explore that on your own if you are interested. The Olama manager, we are injecting the installer and the Olama process. It's a class that wraps around the .NET process class. So some things to help us just work with the server process. When you ask the manager to ensure that it's installed, it will go to the installer. Can the installer make sure that Olama is installed? True or false? Start the server. If it's already running, then get duck out. Make sure it's installed. So that's happens here, happens again here. And then we start it. Process start info. Create the process object. And for this demo, it's fairly basic. We're taking the output, standard output and standard error, running that through our own logger. And then we can stop the server process. Let's see. You can see there's a series of commands here. And what these are doing, got the different Olama command line set right here. And these are it's just running the command line. It's not actually connecting to it as a server. It's running it from the command line and then pulling the results into standard output. The Olama installer, I've already run this once. It takes, the first run is going to take a bit longer depending on your connection, because let's see, it's install for Windows or Linux. I'm running on Linux. I have not tested the install Windows yet. Pick out and install directory based off of your operating system's local app data rules, and then we are downloading this archive file using the Linux command line to unzip it, basically extract it. So download, extract, make sure it actually exists wherever you stuck it. Install a directory, and then for this version of Llama that we're using, it sticks it under the bin folder in the install folder. And then download file async. I had to work with this a couple of times. It's such a big file that the download process kept failing out. And this it'll pick up where it left off if needed. And it'll do a number of retries. Basically, it just keeps trying until it can download the entire thing. If you run all this now, so Olama is not installed, at least not globally. .NET run project AI NPC. End goal of this project, I've been giving this some thought. I want to see if I can build a little text adventure. It was a type of game that's popular in the 80s. Basically, the game gives you a story, and then you use text commands to navigate the story. And we're going to see if we can coerce this language model into helping us navigate through a text adventure. But you can see it pulls the Quen model, and then lists any models that are installed. This must be from a previous. I had the Llama server installed a long time ago. I haven't worked with any of those in a while. Anyway, lists the models and then stops the server. All that works, and it's like should be able to run it multiple times in a row. If we weren't properly killing the server, then on the second run it would fail because it would say the server port is already in use. So we can launch the thing. The next phase of this project, we need to be able to talk to it. I'm going to be using the Llama Sharp library. So that's this one here. And the way this works, it connects to whatever Llama server URL you feed it, and then has a pile of .NET friendly models, commands, all wrapping the thing to make it easier to communicate with. It can hook into some other Microsoft libraries that currently not planning to use. I might change my mind later. But it seems like a pretty thorough library. So using Llama Sharp, what we're doing here for the app settings, you can see we're configuring the URL we're connecting to and what model we want. That's also in the JSON. Let's see, don't need that. Going back into our main state, constructor is basically the same. The manager and installer are gone and are replaced with this Llama repo. This one contains the Llama manager that was written for the previous branch, manages the server itself, and then Llama Sharp provides this Llama API client. Now, stepping through this a little bit, now when we run, we start by loading the state. So we got telling the repo to initialize itself and then set the model that we want. And so initialize async, that handles the ensure installed, start the server, and then once that's all done, create the Llama Sharp client. Set model async. We're getting the list of models from the server through the Llama Sharp client. If the model we want is not in the list that was returned, then we pull the model. Otherwise, there's no need. And then we can set our selected model. So that's the load state. And at the very end, when we unload everything, so I'll try catch finally, so that if something weird happens, we know it's being unloaded. And that will tell the repo to dispose itself, which will tell the manager to dispose itself, which will stop the server and dispose of the server process. We really want to make sure that no matter what, that server process is killed. Otherwise, it's like things are going to get weird when you try to rerun this app. And see, when you stop the server, we're also deleting there's a PID file. The way that works, server process, oh yeah, if we go to the top, in this branch we're adding something up here, if I remember correctly. Oh, let me find it. The Llama process provides us with the process ID, which is currently not being used. If the PID file exists, then this will load the process and then kill it. Trying to see if I'm actually writing... Oh yeah, there it is. Server process ID. I wonder if I had a bug in there. I wasn't expecting to see server process and the Llama process. Makes me wonder if I missed something, but I'm not sure. I'm going to come back around to that. But back to the main state. So we load up the system, and the Llama repo can give us that same report from the last branch. List the installed models, report on any running models. And then this is actually doing the text generation. And there you go. Testing. My name is Trey. How are you today? Oh, hello. I'm just a virtual assistant. So, there you go. It's able to respond. And the Llama Sharp library has this built-in chat system. A chat object that will hold on to the conversation memory for us. The decompiler is not super useful. It's an open source project though. It has a list of messages, so we can use that to serialize the whole thing if we had to. Anyway, run the chat process. We have a very basic REPL loop. Write out the prompt, wait for the user, and then streaming the response. Hey there, who are you? I'd like to know more about wombats. Oh, there you go. Now we know something about wombats. And then the big question, did you make any of that up? Okay, Quen insists that Quen would not lie to us. And then entering a blank line will break the loop. So, we're able to have a simple kind of conversation. Cool. Next thing is tool use. Now this was kind of neat to figure out. I wasn't sure if it would work. The documentation wasn't clear. It's like the more advanced Quen models had notes about tool use. The 0.5 billion parameter model, it wasn't quite as clear. What we're doing here, the biggest change, well, there's several changes. Okay, using the Spectre console library to pretty up the display a bit, and then loading up the system like before. Loading and unloading is basically the same. We're giving it a system prompt. When you create a chat through the repository, you can optionally provide a system prompt, which gets funneled into the chat object creation. And then we're also feeding it a weather tool. And see if it can use the weather tool to tell us something about the weather. I tried wiring this up the way it's described in the Olama Sharp documentation. You're supposed to be able to just feed it a function within a special attribute, and then it has some sort of it has its own compiler built in that will turn a function into a complete class. But my compiler wasn't finding the class that Olama Sharp was building for me, so I basically reverse engineered the thing. There's a base Olama tool. You have to inherit from tool and invocable tool. Create a function, give it a name and a description. And the invoke method handles converting any arguments coming back from the model into what is needed by your function. There's a lot of type conversion here, and I'm sure that some things have been missed. But if you want to create your own tool, you have to add property descriptions, and you have to implement invoke internal. So we have our weather tool. It has two parameters, the location and the units. And then it has a different response on whether you are asking for the temperature in Fahrenheit or Celsius. So, let's take a look. Alright, much prettier display. Who needs a graphical user interface when you have this? Hey there. Sure, what's the current weather condition in insert location? That's weird. But, I'm not sure why it's insisting on insert location. Currently very cold with temperature of approximately pi degrees Fahrenheit. What is the temperature in Celsius? Current temperature is... That's not using the tool. What is the temperature in Dallas in Celsius? So it picked up the tool for the Fahrenheit conversion. Let's run this again from the top. What's the weather like in Dallas? Here, let's do this a little different. Dallas is not a real place, but the temperature there is 23 degrees. That time it is using the tool. This is one of the weaknesses that I've found with small language models. You really have to go out of your way to get them to use a tool correctly, which is probably going to keep coming back to bite us over and over again, but we can figure it out. There's a lot to be gained from using a small language model. You are a helpful assistant. Your first priority is to use tools when they are relevant. Only answer from your own knowledge if no tool applies. If you do not know something, then say so. When the user asks for the weather, always call the get weather tool. Do not guess the weather. And it still guesses the weather sometimes. It's like it's almost like it's forgetting its own system of prompt. What's the weather in New York? It doesn't know. What is the current temperature in... Oh, how do you spell Fahrenheit? What's the current temperature in Fahrenheit in Albany? Well, it's pi degrees. Then it knew exactly what to do. Couldn't tell me the weather, it could tell me the temperature. So it's almost hit or miss whether it's going to use the tool or not. It uses it more often than not. But the system prompt, basically, if you're going to use this for a production level project, you're going to have to keep tweaking the system prompts and test it with anything you can think of. And you're not going to be able to perfectly make it do anything. Of course, when you're trying to create a game around a fictional story, then that might be a benefit. Okay, so we're making progress. We can have a conversation. We can get it to use a tool. The next example, and it's the last one I want to show you today, has to do with actors. We want to build a story. We want the story to have multiple actors. And let's see. This is the part where it starts getting complicated quickly. I know there's a build error in here, I just need to find it. There it is. And disable this for the moment. The shopkeeper prompt is not done. The system I have right now builds characters from various factories. We have a character factory, and I did use a language model to spit out some random characters. So a character can have some personality traits. Name personality traits. Another name, another set of personality traits. And we have locations. The village can have a name, description of its location, some traits about the village, and recent events. All of this is, like, I may end up changing this later, but it's like, if you wanted to be able to talk to someone and somehow the player gets a quest, that would get pulled from recent events. So we take those two, and then we have a list of roles. Role factory, you feed it the character factory and the village factory. And there's also a template engine, which just does a search and replace for key value pairs, used to merge things together. We pulled the assistant prompt into this role factory also, but we're not using it right now. Okay. For building a gatekeeper, we pull a character, pull our village, and then we merge them together. We have the gatekeeper role in the NPC templates, and it says everything that the gatekeeper has to know. Who you are, where you are, what's your job, personality, what do you know, what are you not allowed to do. This is, the Quen model likes to pop out of character. It's determined to be a helpful assistant, which is, I guess it's useful for most use cases, but if you're talking to a gruff gatekeeper, being all rude and short with you, and then ends with, "How can I assist you today?" It is breaking character. So you have to keep reiterating to it exactly what it can and cannot do. Say, stay in character, no really, stay in character, no really, stay in character. And even then it's probably going to break out of character sometimes. Jailbreaking this model is probably going to be crazy simple. Anyway, we're able to build the gatekeeper role from that. going back to main state, create the gatekeeper system prompt, feed that into the chat, and then onward. We're still feeding it the get weather tool. I wonder if the gatekeeper knows the weather. Okay, let's find out. Okay, so updated the banner a little bit. You are running using that model. Type your message. Alright, let's pretend that we're walking up to the village. Hello, who are you? Oh, I'm Bramwell, gatekeeper of Elderwood. How can I assist you today? There's the helpful assistant prompt. What can you tell me about Elderwood? Well, there you go. Small rural village. Do you have any quests for me? I don't think so. Let's see. Area is known for its it's like a little like tourist pamphlet. Say, what about those wolves you mentioned? Wolves are indeed a threat. Remain vigilant. Good to have weapons, but for now, I'll keep an eye out. Thanks, Bramwell. If I can help with something else, just let me know. Let's see. Would it be alright if I entered your village? Of course. Ha. And that's weird. It says, I'm Bramwell. Of course, Bramwell. So, what's my name? Your name is Bramwell. Oh, well really? Then what's your name? My name is Bramwell. Thanks for asking. Do we have the same name? Both of us are Bramwell. Huh. Don't you think it's strange that Elderwood would have two gatekeepers, both named Bramwell? Oh, there you go. Apparently I am Bramwell, and the assistant's name is just Bram. That clears it up. But no worries, we're good friends. So the prompt needs some work. And ultimately, it may keep being weird. Could be that if I fed it the player's name as part of the system prompt, that it'd better be able to, it'd track it better, but that would need more experimentation. That is where I'm going to stop right now. When we come back to this project, hopefully soon, we're going to walk through what we might do to build a little shopkeeper. Done a little bit of work on it already. Basically, you need to have, if you want to build a shopkeeper, you need to have a shopkeeper prompt, which I have not really built. Well, okay, so there's a shopkeeper prompt, but haven't really tested it yet. It's going to need a set of tools. It needs to be able to list out what's for sale. Needs to be able to figure out if the player can afford an item. And then it needs to be able to manage the transaction. Take gold from the player, give the player the item, add gold to its own inventory. Which is kind of a neat set of tools to test this with. Well, we'll need an inventory for the shopkeeper, and we'll need an inventory for the player, instead of like how much gold does the shopkeeper and player both have. We might even give the player a name, who knows. And see if we can get this to manage a transaction. So, stay tuned for that next time. And that's it. See you later.